of religion. This goes into the history and comparative religions in the 19th century. The scientific method will develop a history of religion, comparative religion, sociology of religion, psychology of religion, phenomenology of religion, and we're all the way to universalism because it's all reductionism. That religion, the essence of religion, Rudolf Otto will say it's awe. Well, if that's what it is, then the gospel's finished. So we better find out whether that's true or not. Now we get back to Galileo. But we'll touch just enough material to build up in chemistry, and when the periodic chart in the little Newton materials in the library, I have the periodic chart there, though I have not seen a handbook, chemistry or physics handbook. If those of you that work in the field have a brand new one, I don't have a brand new handbook. I used to look when I was around the library, examine the handbook, every new edition of the handbook. But that's just specific information. That is not a paradigmatic shift. Now let's return to Galileo, the material. Galileo considered two hypotheses regarding motion. Now what this revolution is about is the explanation of a motion. The Greek model of explanation of motion is a failure. The Newtonian revolution will give explanatory power to all kinds of things. And then when chemistry develops, the motion that we found macro in the heavens, that's how atomic structures will act in the micro world. See, the same forces are at work in the macro world and in the micro world. Now, science starts in astronomy. Don't forget that. It's very important not to forget. Astronomy and physics, the method develops. It develops what I would call in the inanimate range, and then by 19th century, this method is applied to the social parameters, to the psychological, social, linguistic, intellectual parameters, religious parameters, and wipes out any differentiating category in the system. So Christianity has been refuted, period. So in the invisible world this way, atomic structure acts the same way that the big picture acts. So it looks like the same laws. The laws are universal for how planets and comets and suns and moons and stars and within the invisible realm of the atom. Same laws are at work. Now, you see, just a tiny bit, electricity is important because when they start breaking into the atom, you will have positive and negative charges, and you remember this from grade school science. Positive and negative charges of what? Huh? So positive and negative charges, you get larger and larger explanatory power, and when you're going to interfere, so you can put oxygen, that's a gas, and what? Hydrogen, that's a gas, and you put them together, see, separately they would kill you. You put them together and you drink them. Now what happens to the characteristics before they were combined? See, they have characteristics by themselves that are no longer present when they're combined. Now that's quite simple. All that. Now here's Galileo says, according to the first, the increase in velocity of a freely falling body, it starts out with a simple thing, freely falling body, is proportional to space traversed. Galileo argued, mistakenly, as we know now, that one consequence of this assumption is that a body should travel instantaneously. And the Planck-Heisenberg's indeterminacy principle was that there is action, instantaneous action. That seems to be a contradiction. See, from a static position, instantaneous action. See, even in a machine has to stop before it can go the other way. It has to stop and go the other way. But there has to be instantaneous action, or the motion would just be continuous in one direction. He believed this was impossible, he being Galileo, and therefore rejected the proposed law of increased velocity. Now Galileo next considered, this is where we were last time, the hypothesis change in velocity is a freely falling body during an interval of time is proportional. Now the proportional is what? See, time and space, he did one on space and he did one on time. Okay? What is proportional?
Measurable.
All right, it has to be measurable relationship. See, now, the shape didn't make any difference. The color didn't make any difference. How it smelled didn't make any difference. How do you know that? Well, he's already presuppositionally stripped away. But the color doesn't make any difference. The shape of it doesn't make any difference. It must have some ultimate behavior pattern that can be described. And this is what we said, V equals AT, where V represents the velocity, A, the velocity acquired in 1 second. Like the speed, Michelson Morley, speed of light. Well, you certainly don't see the speed of light because we see through light. We don't see light. We couldn't see without light. So perception is contingent on light. So empiricists, you hear all this collapsing right before their very eyes. We learn by experience. Learn what? Now, A is the velocity required in 1 second, and T, the number of seconds the body has fallen. Time, space, velocity, mass. Very simple. It may also be expressed by saying that the acceleration of a falling body, defined as a change in velocity during any unit interval of time, is constant. That's where we start letting it. It's constant. Now, how would you know it's constant? By repeating it. The public availability of repeating experience. See, is that way for you? Does it change? We're on the way to the principle of universality in science. All the way to the 50s, 60s, and 70s, when New Agers used physics and biology to say, hey, this opens us up to a new world, to Hindu physics. See, Hindus don't do physics. Buddhists don't do physics. Not from their religion, they don't. They may adhere to that and do physics, but their physics does not derive from their religion. It's deadly to that. Now, but the assumption that the acceleration is constant could not be put to the test directly. Galileo was compelled to strengthen his argument by deducing other consequences from the acceleration hypothesis and showing that these consequences were capable of direct verification. This is after public verification of his explanatory system. Other than that, we could say anything. See, that's the difference between, Popper, a little paper on demarcation and Kant and Popper. See, they're asking, what's the difference between common sense explanation and scientific explanation? Is the demarcation between common sense and science? The argument was strengthened because these consequences had not previously been known to be true. For example, Galileo deduced from hypothesis V, it was AT, the proposition. This is what he deduced. And what he deduced from that proposition was testable. Here's the proposition. The distance freely falling bodies traverse are proportional to the square of the time of their fall. Now, that's not direct common sense experience. That I realize that this baby has fallen at the square of the fall. How would you know that? What does the square of the rate do? What's that do?
Accelerating. Increases it geometrically.
Now, it increases it geometrically. It's testable. You could test. They have no precise clocks. They have no precise instruments. So he just marked off units, same units. That's how he counted units. See? But once they get precise tools, but don't forget, there are no technological tools that are not already theory-laden. We have highly complex instruments today, but they're already theory-laden. You couldn't build them without building the theory into them. Okay? Okay, so anyway, that is not common sense observation. You know, the square. Square is not a common sense detail. Common sense in the reads in our heritage and pragmatism sees a dead horse. Pragmatism can't explain science, and common sense can't explain science. So why would our heritage be commonsensical? Don't confuse common sense with common sense. Okay, please. The distance freely falling bodies traverse proportional to the square of the time. Now, he is saying that the time has more to do with the velocity than the space. He didn't say square the space, he said square the time. Okay. Now, instance of this rule can be established experimentally. Now, don't confuse experimentation with mere empiricism, because experimentation already has theory loads in it. Okay? Thus, a body which falls for 2 seconds, now I'll try to keep this quite elementary, for 2 seconds, a body that falls for 2 seconds travels 4 times as far as a body which falls for only 1 second. That's how you test it. Now, one more time, because it's important. A body which falls for 2 seconds traverses 4 times the distance as a body which falls 1 second. That's how you know the square. It's geometric. Now, if that actually describes freely falling bodies, this is what Galileo... But see, he can't explain this. Galileo can't explain this. We have to come to Newton. We have to come to this book. We have to come to the journals and the work of Newton between 1666 and 1687. That gives the explanation. This gives explanation like this. See, if you drop something perpendicular, it ought to just fall perpendicular. But if you have force, see, in that system, but where do the planets get their force? What's the source of the force that keeps them going? It's apparent upon observation that they do keep going, and at the same place every year. We've already determined that. And so the square, the difference is how far you measure the units. See, they had no precise measurement. See, science is about measurement. And measurement is precise measurement. And if the epistemology of science is measurement, then its truthfulness is in direct relationship to its measuring capacity. And that's why social studies and religious studies want to have some math in it so it looks like they're measuring something. But see, they aren't always measuring what they think they're measuring. This is what you do in educational psychology. They think they're measuring intelligence. Yeah. You couldn't be very intelligent if you believe that. And whole school systems, see, put children in. See, you know from the street, just behavior, just watching them a couple of weeks, you can get the behavior pattern of a child. You don't need these dumb reports that cost $75 or $100 to see whether they're stupid or whether they can count or not. You already know that by the time the information gets to you. But it does get work for some people. And I'm not totally opposed to that. Now, if a body falls 2 seconds, travels 4 times the distance. So you can test that, can't you? 2 seconds, 4 times d distance. You can make, how did he do that? He just marked off units and counted on the clock. See, that's not a heavy precision, but you could get some accurate. 2 seconds and went through 4. 1 second, 2. So that's the square. Okay? So that's not difficult. Now, instances can be established. Now, here's another matter. A body falling 3 seconds travels 9 times as far as a body falling 1 second. What's that? It looks like, at least this suggests, that all freely falling mass operates according to the principle of universality. All mass falls the same rate. Well, we get over here in chemistry and physics and materialism and physics, and
And there's hardly any room for spirit or talk or God or Holy Spirit or spiritual. That's what gives university people fits. They don't know what spiritual is. Well, most times church doesn't. Sometimes it's frothing at the mouth or rolling in the aisle or shouting or something. Now that might not be spiritual. It might be something else. Now, this therefore, Galileo says, strengthens the evidence for the hypothesis that bodies fall so that their acceleration is constant. Now he went through several experiments, and it's in the notebooks, and Newton demonstrates this. Now if all behavior is like this, then every act of an event of mass falling fits a universal pattern. If that's true. Therefore, it's constant. That means the proportionality never changes. If that's true, now you clearly know on a finite amount of evidence you wouldn't know that it never changes. But on the assumption that the universe is ordered, you would put down the mathematical statement that it is constant. But the constancy equations do not derive from what? Then or now. Do not derive from anybody's experience because you haven't had that much experience. Now, if the world acts like that, that's a different thing. You work in physics and chemistry and different things. That it acts that way, I don't doubt. But don't confuse the fact that it acts that way with limited amount of justification. Now that means it doesn't act that way because you have a finite amount of evidence for it acting that way. It acts independent of that, and the evidence merely justifies you rationally holding that. But the universe doesn't act because you rationally hold anything. Now in a similar fashion, Galileo deduced other propositions from acceleration, all of which he could verify with much precision. Now precision, see your marks on a board or something, but understand that's still testable in principle with high-level electronic laser precision. Now in this way, the evidence for the hypothesis is increased. We're on the way for something very important. We're on the way to the application of math to scientific proof, and that will develop into probabilism. Now, from other classes that you've had, church history or several classes should have mentioned this, what was the central critical problem in the 17th century? When I say the, I'm assuming in the Western world there was the. Why was a confrontation between this spirit of probabilism and the classical views of the authority of the church? You've just forgotten if you've had church history and no one mentioned that.
Well, now, Doc, that's going to come right into the systems of miracles, Hume, and all that sort of thing, because of the Newtonian machine.
Yes.
Now, how should the church have responded back to that when it hit on the miracle?
Very, very important question. And given the data in the 18th century, given the data, no informed person could have been a Christian.
I mean, just reading the miracle accounts is not going to solve that problem.
No. From Hume and Kant forward, they say we don't doubt the account, but they're myths. Why? Because things like this can't happen. So there can't be any evidence of things that can't happen. Evidence are only for things that can happen. Where'd that come from? Studying at a real school in exegesis? No! Science. 18th, most of the 19th century, the church, both Catholic and Protestant, responded by quoting the Bible. This is disastrous. It's the historic origin of losing the universities, and I don't mean they're any better, but losing the intellectual element. Christianity progressively loses the creative mind. And today churches just aren't just stacked full,
They should have been looking at this to see the order that had to be a creator that brought it all into existence.
My precious brother. See, education. Watch this now. This is about us. This question, this is important for our purpose of being here. education. It is in the midst, 17th and 18th century, that we start getting the two cultures. C.P. Snow's thesis, what was that? And it's a real issue for us, so it's not digression at all. What's the two cultures?
Sacred and secular?
That's not false, Leonard. You know, I was letting you have one more year of life because you'll amount to something, but help me more. I need more help than that. That's not false. See, this worldview won't give you any sacred or secular. That's why the Bible's opposed to sacred secular. The Bible doesn't know anything either.
You get an educated and uneducated.
No, you're not going to help me. I've got to put this down myself. It is between the study of the humanities and the classics and the study of the sciences and math. Isn't that what we're doing here? Well, I don't want to read literature. I didn't come to school here to read literature. I come here to study. Now, you see, you get the Industrial Revolution in this context. See, of Newton. Application of steam, new sources of force. It changed the world. You went from sailing ships, unless you got $3 or $4 million to have a sailing boat up. Well, you don't need a sailing boat up on Lake Michigan. You just need it on roller skates. Now, see, humanities, classical education, see, was Greek and Latin literature. Classical education wasn't math. And the liberal arts, even though the liberal arts did astronomy and math, they never applied the liberal arts to anything. And by the time we get to the 20th century, liberal arts, what you go into if you don't know what you're doing. That's what you take. You get more and more, less and less. Now, humanities, now notice in the scientific world, what possible bearing could reading Cicero have on the scientific world? Well, it's over the kind of people that you're going to produce. So we're not only going to lose the Christian view in psychology and sociology and anthropology, paleontology, classical physical anthropology that's developing here out of geology. You hear all those, some of you are specialists in those things. Greek and Latin, and then the Bible. Bible was literature. What is the point of reading literature?
Well, if man is reduced to a machine, then what good does it do to learn anything?
The first thing he was reduced to is a machine, and then he was reduced to a beast. He's an animal. He's a biological paradigm. He's a machine here, and he's back to a machine. That's why I have a little chart on the cognitive revolution. See, because if man is reducible to computer analogs, then the Christian view of man is out of the question. If the Christian view of man is out of the question, there is no point us stumbling around in this dumb, ugly room. But if we can manage the truth, we have a reason for being here. And if the church ever found out that the Bible is about everything in the universe, it might get more exciting in churches. I can't promise that, but I would imagine it would. Well, the two cultures is, if you're going to have a scientific world, why do we need to study the classics? I'm just going to preach. I don't need to study Greek and Hebrew. I'm just going to be a youth minister. I do not need to understand the world, and certainly not understand youth. Because I are a youth. See that? Grade school, high school. Bring me the names, please, of youth ministers that are aware of this. I know dozens. I do not know one. I'm not saying I know all of them. But the ones I know are successful, and they'll not be fired, but they don't know that. And you can only ski so long. And you can only take so many canoe trips. And you can only go to the Swiss Alps so many times, unless your parents are extremely wealthy. And you can only mountain climb twice a year, once in the spring and once in the fall. But the kids are crazy about all that. There's no question, because they're probably just crazy. Now this it drives a shaft between science and classical education, particularly the Bible. Now you have to deal with this in history, Christian education, or history of education classes. It's not possible not to have had those classes without that. And therefore, if you've had such classes that didn't deal with this, you had a Christian science class. But it was possible, that it was only evident that the hypothesis was increased. Probabilism. Authority versus probabilism. We're on the way, after Newton and these developments, of having a crisis in authority. The Western culture will not settle from the top down, will not settle truth matters by authority, either in the Bible or the Pope or the preacher or the priest or the rabbi or any authority figure. Some of you come from Catholic background. Did you go through that when you went to Catholic school? You remember that, or did you pay any attention to the priest? By the 60s, pregnant teenage Catholics were thumbing their nose at the priest. That meant that the authority crisis had arrived.
So that's why in that stats you quoted there, 3% would believe that science would be, hold science as authority would be bad.
We're in another crisis.
Because they have no authority.
That's why New Age, they're gobbling up touchy, feely. See, that's as much a crisis as on the other end. Huh? To think that science has no more explanatory power than their feelings. Huh? Does that make sense? See, we get it on both ends. Top and bottom. I mean, ends of the spectrum, not both ends. Now, nevertheless, the evidence for acceleration hypothesis always remained only probable. Now, that's the key thing. That's always said tonight. Probable. Well, why would that bother anybody? Because the Christian enterprise, both Catholic and Protestant, had known truth, absolutely certain truth. And now you're developing a method that only gives us probabilism. Well, no wonder I'm upset. Now, this probabilism will develop through the social sciences into relativism, into contextualization, into the loss of all truth claims. But that's just an extension of certain things that develop. Now, the hypothesis is only probable on the evidence because it is always logically possible to find some other hypothesis from which all the verified propositions are consequences. Now, if you say, hey, Jesus rose from the dead, you've got to accept Jesus Christ because he rose from the dead, and here's 7 irrefutable reasons. Here's more evidence, and I'm writing another book on more and more and more and more and more evidence. And then I've got 2 more editions coming out with more evidence. Haven't any idea what happened to the theory of evidence. Because what is evidence in math, in physics, and biology is not the same things as evidence in all parameters. Evidence is not a univocal term. And all that's common sense talk. Well, both people that are still commonsensical, well, that will appeal to them. But people on the cutting edge, they said, what? Hasn't anyone told that person to stop that? Not even harmless. See, they thought it was harmless before, but when you get 1 book on evidences, and then 2 on more, and then 3, and more, it's like singing that song. I'm sure God's God, because he would just zap a song leader in a congregation, power. Very outrageous. The pagan priests behave more morally acceptable than song leaders do that song. So, probabilism and procedure and evidence, we find that he selected some portion of experience for study. Now, this is point number 2, probabilism. Let's put that down. And secondly, so truth, absolute certitude and truth versus probabilism. See, instead of saying this is probabilism, but statistically all you can get is probabilism. So truth, how could the Bible and the church have the truth? And the most powerful instrument devised by man could only be probabilistic, and it could tell him more about the world and himself than study of the Bible could. Well, within a century, see, that'll be devastating. I think it's answerable, or I wouldn't even have mentioned it. But, see, until certain views of science come apart, you couldn't have held on to both. You're going to have to two-pocket faith. It's going to have to be fideistic. Faith justifies itself. Well, then faith justifies everything in the universe. Everything is legitimated on the basis of people believing it. If merely believing it confirms it, then we're in a cosmic loony bin. So the procedure and selection. Now this is science. High school textbooks still say there's 5 steps. This is dumb. See, why they even allow? They should at least burn a cross in their front yard. You got these steps, you gather all the evidence. There's no such thing as that. Why would they keep saying that, even for grade school and high school kids? I don't know. Now the next thing is selection. And that you select, and selection always entails presuppositions. We're either going to deal with all the evidence that we wouldn't even know whether we had them or not, would we? There'd be no way of knowing that. Or you select, and selection takes a presupposition to select. Now, I didn't say the selection was wrong, right? I said, are you aware that any selection procedure carries a presuppositional impact? It's impossible to do science without presupposition. But why will positivism in the 18th, 19th century said, we just deal with the facts, man, just the facts. I don't want your interpretation, just the facts. And then the Bible is an interpretation, see, so we don't want the biblical interpretation, we just want the facts. We're getting back of the data here to the facts. Is there anybody going to get back of anything to any fact? That's all German myth. See, it's not over conservatism or liberalism or neo-orthodoxy or post-Boutmannianism. All those are dumb moves. It's over the procedure of the scientific enterprise that sets the perimeters of the discussion in philosophy and theology and all categories. So selection, that's two things. That's all we've said, just two things, presupposition. Now therefore, science isn't just an interpretation of experience. It is the interpretation of some experience. But the mind is already determining certain things. Now the mind has a propensity to ask for explanatory systems. See, if the mind didn't have natural propensity to want to know, and Aristotle said all minds have natural propensity for knowledge. Well, I think the average student and teacher would be a refutation of that. It just isn't the case that everybody has a natural propensity to know. But if we don't have a propensity, I didn't say it was natural, as Christians, if we don't have a propensity to know, we will have a propensity not to know. And that's deadly. We can't have it both ways. So his experiments from the Tower of Pisa resolved some of his doubts. But the resolution of these doubts only raised others. If the behavior of a freely falling body did not depend on their weight, upon what did it depend? He's on the way to do something else. That regardless of the weight of an object, same behavior pattern. Even for planets and comets. And then in the 20th century, even for electrons and mesons and positrons, they'll all move. Same laws. Same move. Now watch it. If the behavior does not depend on its weight, well, what's that a problem of? Well, Aristotle said the heavier an object was, the faster it falls. But this is not merely a correction of Aristotle. This is a paradigmatic revolt against the whole explanatory system of the Greeks. So it's still set up with...
That's held by the church at the same time, though.
I don't want to hear it this late. You and I know it, but don't tell anybody else. That's correct. And see, it's not just, it's over paradigm. I said that was a funny word, see? And some have heard about it from other classes. But see, Kuhn's thesis was the history of science is a history of some incremental increase of knowledge, of course. But radical breaks are paradigmatic revolutions of thought, different ways of seeing things, seeing things, seeing things, seeing things. That ends empiricism, and it ends incremental evolutionary epistemology. Well, then why is Karl Popper one of the most brilliant evolutionary epistemologists in the world? Because the only alternative is some kind of Christian worldview. Okay? Now, the ancients, or the classics, as well as their contemporaries, had always isolated some properties of bodies as irrelevant. But notice that's a theoretical relegation of irrelevance. You know, as I said, color, shape, smell didn't have anything to do with how it fell. So things are being stripped away. This will develop into reductionism, into materialism of the 18th century. I'll bring next time, if I don't forget about it, Lang's classical history on the history of materialism. If you're around university libraries, that's a classic tool up to top of the 20th century. Now, that's old. Therefore, it didn't include Einsteinian revolution, didn't include Planck-Heisenberg's indeterminacy principle. But see, materialism's finished. See, after the paradigmatic shift in the 20th century, materialism's finished. Finite matter, curved space, finite matter must have a finite origin. Finite matter cannot be infinite and eternal. What's that mean? Must have an origin. That's the first time we could talk reasonably, rationally, in the name of science about creation for 150 years. Did I not tell you the first time? The first thing to go was the concept of creation. Then, people's faith still held on no matter what. See, science was the devil's work. Well, some of it, a lot of devils ever played. Well, we'll have a little break, and I will have to terminate Galileo because I've got to move to. But Galileo raised all the problems that will take Newton's equations to resolve. So that's why the books accurately say the first scientific revolution took place between the work of Galileo, 1620, and 1720-30. See, out here, Newton, in that period. Now, that was a revolution. That was a paradigmatic shift. And from that time forward, see, up to this time, the Latin word revolution meant to go around the circle. You know, just keep going around like this, rise and fall, this high point, this low point. Things get better and they get worse, you know, revolution. But see, revolutionibus, after this scientific breakthrough, will be a radical break with the past. Therefore, science does not have its origin in the Greeks, except semantically. I didn't say they didn't have a science. I said they didn't have one that worked. Descartes had a science, but it didn't work. And that's a clue something's wrong with pragmatism, with Peirce, Dewey, and pragmatism in the 20th century. Lots of things work that aren't true. But people say, I don't care whether it's true or not. I want to know if it's relevant. See, epistemology and semantics aren't the same thing. Meaning and truth are not the same thing. Whether something A, B, C, D is the truth is one thing. Whether it is relevant for me is another thing. But don't let anybody confuse truth and relevance. The Sistine Chapel is not relevant to a blind person, but it's still there. A Bach or Beethoven orchestration is not relevant to a deaf person, but it's still there. Perhaps the greatest music ever written, and both Bach and Beethoven had all the notes in their head. They never corrected or went to theory school. Got C minus or F plus on these dumb chords. Surely all those chords God would have wanted lost. But they keep coming up with those strange things. We'll have a little break. You can have it in your arm, nasal passage, or tibia, any place you would like a break. I'll go down and check the Madam Typist. You may look at these books. Please do not tear any pages out of these books. This book, if you have some seriousness, I would encourage you to get these two books. See? We really need a class to read those and then get on with these things. Okay? And come back. If we're not done, come back. Alan Turing, the logical engine. Did you see this? The Turing machine. I have comments on that in my math paper. It ought to be. I put it up, but you never can tell. So I'm basically we're abstract. Oh, right. See, metaphysics, by the time this developed, see, we got method over metaphysics. And from Kant forward, said we don't need metaphysics. You got it. And the proofs for God, the classical proofs, were based in Greek metaphysics. So when that metaphysics was proved because of science, see, God's going to get it because both Protestant and Catholic used those procedures, you see, in proof for God's existence. And Aristotle's 5 steps were not proofs for God's existence, but God was a part of the explanation why the universe is rational. His steps were not proofs for anybody's existence. So by the time Catholics and Aquinas and people used to, so God gets it here for the wrong reason. Does that make sense? Let's see. Yes. That's just one of them, but you know, any of those things.
Did you just want us to hand this in to the library then?
No, I want a copy of it. Yeah.
Okay.
So if you,
Okay, we'll make a copy.
because I want people to be aware of it. See, I don't want that work just to be done, and I'll comment on that later.
Okay.
So many people are only here a day.